Good morning, dear students. Welcome to the next revision part of the atomic structure. In the first part, we have learned the history of the atom, the John Dalton theory, and the various model of the atom based on the experiments like Thomson model, Rutherford model, the Bohr model. So all this model of the atom are totally based on the classical mechanics, where we are assuming that the electron behaves as a particle. The new era come up when the quantum mechanics explain the structure of the atom. So in this lecture, it is to be very interesting to have the new vision of the structure of the atom, which changes all we have seen the model of the atom previously. In this lecture, we are going to cover the Sommerfeld model of the atom, the Zeeman effect, then come up the quantum model of the atom, in which the three of the scientists involved, the de Broglie equation, the Heisenberg uncertainty principle, the Arvin-Schrödinger equation, then the atomic orbital concept with the shapes of the various atomic orbitals. What will be the learning outcome of this lecture? The students will be able to understand about a brief detailed structure of the atom with a new vision with Sommerfeld, Zeeman and the quantum mechanical model of the atom. So after the various limitations of the Bohr model, that it failed to explain the multi-electronic atoms, it does not explain the shape of the molecules, as well as the Bohr model can't explain the chemical bonding, size and geometry of the molecules. The Sommerfeld did the same experiment done by the Bohr, and he observed the line spectrum of the hydrogen atom with the help of high resolution microscope, and he found that other lines are also associated with the main line of the spectrum which was observed by the Bohr. So in order to explain that observation, the fine structure of the spectral lines, the Sommerfeld introduced two main modifications in the Bohr theory. According to the Sommerfeld, the path of an electron around the nucleus is an ellipse with the nucleus at one of its foci. The velocity of the electron moving in the elliptical orbit varies at the different parts of the orbit, and this causes the relativistic variation in the mass of the moving electron. So, as the three-dimensional, the electron is moving around the nucleus and the path can be elliptical, circular. By the Bohr model, it is explained that electron is moving in a circular path. But Sommerfeld has given the modification that the path should be an elliptical also around the nucleus, which give the relativistic variation in the mass of the moving electron. When the elliptical orbits are there, one has to deal with some of the quantities. The varying distance of the electron from the nucleus, because when the electron is moving to the elliptical orbit, the distance varies from the nucleus, as well as the varying angular position of the electron with respect to the nucleus. That is angular position, that is azimuthal angle. So he gave the concept of the suborbits or subshell, and the path is defined as the elliptical also, which was not explained by the Bohr. Bohr is assuming that the electron is having the fixed velocity and is revolving around the circular path. According to the Sommerfeld's model, for any of the principal quantum number, that is orbit n, the possible orbits of varying eccentricity is called suborbits or subshells. Out of n subshell, one is circular and remaining are elliptical in shape. And these possible suborbits possesses slightly different energy because of the relativistic variation of the electron mass. So Sommerfeld gave the observation of the subshells or the suborbits, which is having the circular as well as elliptical path. So let us understand the Sommerfeld model of the atom. Consider the first energy level, that is n is equals to 1. The subshell value L is equals to 0. In this energy level, there is only one orbit or a subshell for the electron. When the value is 1, there can be only one orbit or a subshell can exist. Also, when A is equals to B, the two axes of the ellipse are equal. As a result of this, the orbit corresponding to n is equals to 1 is circular. So, the path of the orbit is the circular in the n is equals to 1. You are able to see here when the principal energy level is 1, there is only one subshell or the suborbit, and for the one orbit, the subshell which is denoted as, which is circular, that is S, and Sommerfeld named this subshell as shape. Now n is equals to 2, we have the two subshells. The one is of the circular path 2s and the another one is the elliptical path, that is 2p. So for n is equals to 2, we have the two subshells having the different path and the different energy. For n is equals to 3, we have the 3 subshell, that is 3s, that is circular, then 2 elliptical, 3p and 3d. Similarly, n is equals to 4. We have 4s, 4p, 4d, 4f. So, depending on the energy level, we have the different subshells and the suborbits on the basis of the circular and the elliptical path. The suborbits have the same energy, but the slight difference in the angular momentum of the electron in the elliptical orbit. So similarly, for the second energy level that we have seen, n is equals to 2, there are two permissible subshells for the electrons, that is L value can be 0, that is S, and 1 is P. So Sommerfeld gave the concept of the subshells or the suborbits. The drawback of this model was he could not able to explain the Zeeman observation or the Zeeman effect which come afterwards. So this model drawback becomes Zeeman observation could not be explained by this model. What was the Zeeman observation which became the drawback of the Sommerfeld model of the atom, which was also known as Zeeman effect? Zeeman did the same experiment as the Sommerfeld and the Bohr did, but he observed the line spectra of the hydrogen in a magnetic field. And what he observed, the splitting of the spectral lines, scattering of the spectral lines of the radiation in the atom. Then with this observation, he suggested that there is the existence of the orbitals in the suborbits where the electrons were moving in a different orientation. It's a three-dimensional path where they can go for the different orientation x, y and z. So the concept of the orbital in a classical mechanics was given by the Zeeman. The orbitals are the path in the suborbits with a different orientation. Like s orbital, which is spherical, so it is having only one orientation. It is dimensionless, but for the p orbital, that is having the three. For the d we have five orientation. For the f we have seven orientations. So we all know that the orbital concept is the quantum mechanical concept, but the orbital, the firstly was described as a path with a different orientation by the Zeeman. So this was the Zeeman observation, that scattering of the spectral lines under the influence of the magnetic field gave us this orientation and the orbital concept. So up to this, we are assuming that the electron behave as a particle which possessing the mass and moving with a velocity, having the momentum. So all these properties are of particle, are of matter. So on the basis of, we are explaining the structure of the atom. Now the another vision come up, and with this the atomic structure vision also changes by the de Broglie hypothesis, the Heisenberg uncertainty principle and the Schrodinger wave equation. They gave a new vision to the atomic structure and come up in a quantum mechanical model of the atom. So now we are moving to the quantum mechanical model of the atom, where the electrons are not in a circular orbits around the nucleus, what the Bohr said. The electrons are in a three-dimensional region around the nucleus, and that region in which we can find out the probability of the electron was the atomic orbital. The atomic orbital describes the probable location of the electron. Not 100% we can have that the electron location is there. Only that's the region where we have the maximum probability of the electron can exist. Where does this model come from? That is quantum model. It comes from the de Broglie dual nature of the matter. Louis de Broglie in 1924 gave a new shape in the atomic structure, and he described that the electrons behaves with the wave and the particle properties at the same time. He differentiates the matter and the wave properties. We are considering the electron as a particle, which is having the property of the matter that possesses the mass, momentum, moves in the straight line, strike at a particular point. The wave properties are different from the particle. The wave do not have mass, do not have momentum. The wave possesses wavelength, possesses frequency, vibrate in all directions, will strike by the surface. And this is the concept of wave and the particle behaving, as the electron is also assuming as a wave behavior. So it is moving around the nucleus as the wave nature. So here you can see the model of the atom. If the electron behaves as a wave, so it moves in the form of wave around the nucleus. It is having wavelength, frequency, amplitude. So de Broglie gives this concept that at a time if the electron behave as the wave and the particle, how we can calculate it. So he derived an equation called de Broglie equation. What he does, he combined two equations. The equation, Einstein famous equation, that is the matter energy relationship, E is equals to mc square, where E is the energy, m is the mass, and c is the speed of light. This is the mass energy relationship, the Einstein famous equation. He used this equation, E is equals to mc square. The second equation, using the Planck theory, which states that every quantum of a wave has a discrete amount of energy, that is E is equals to h nu, that is of a photon, packet of the energy. E is the energy, h is the Planck constant, and nu is the frequency. So by the Einstein equation and the Planck equation, he found one similarity, that both are the energy forms and energy can be transformed to one another. Since the de Broglie believed that the particles and the wave have the same trait, and he hypothesized that two energies would be equal because both are the energy forms which can be transformed to one another. So he equalized the equation of Einstein and Planck. mc square is equals to h nu. Because the real particles do not travel at the speed of light, the de Broglie submitted the velocity v for the speed of light c, and the equation become mv square is equals to h nu. So replacing c, we put the velocity of the particle v square. Now, if we convert the equation of nu, that is v upon lambda. If we substitute this equation, the frequency value, it becomes mv square is equals to hv upon lambda. Then we can simplify the equation. We have the wavelength can be determined of a particle, that is mv square upon hv, cancel h upon mv, or we can also say that lambda is equals to h upon p, that is momentum. So finally we have the de Broglie equation, that is lambda is equals to h upon mv, or that is can be the momentum, mass into velocity is the momentum, Lambda is the wavelength in meters, h is the Planck constant, v is the velocity in meter per second, m is the mass in kilograms. So by using the equation, we can have the calculation of the wavelength. Find the de Broglie wavelength of an electron having the mass 9.11 into 10 to the power minus 31 kg moving at 2 into 10 to the power 6 meter per second. By using the de Broglie equation, we can substitute the value of h. We have the mass given and the velocity. So we have the wavelength 3.6 into 10 to the power minus 10 meter. Compared with the classical electron radius, which is about this is relatively large wavelength, which cannot be ignored. So this can be find out by the de Broglie. We can assume if the mass is given and the velocity is given, we can easily find out the wavelength of the electron. Here the another example is the wavelength of a baseball. The baseball of a mass 0.15 kg is pitched at 45 meter per second. What is its de Broglie wavelength? If we determine the wavelength of this baseball, we can determine using de Broglie equation. Putting the value of h and the mass with the velocity is given 45 meter per second. We have 9.8 into 10 to the power minus 35. So this diffraction effects of the baseball are negligible. So it is also having the wave property, but its wavelength is very small figure, which cannot be compared with the size of the ball. Understood? So de Broglie is mainly used for the microscopic objects, which is having less mass. Less mass is having higher wavelength, which cannot be ignored. So the quantum is very much useful for the small objects. Werner Heisenberg in 1927 gave the principle of uncertainty. It is impossible to determine or know both the position and the velocity of an electron simultaneously. If we determine the position of the electron with high accuracy, its velocity will be uncertain. Similarly, if the velocity of the electron is known precisely, the position will be uncertain. Exact picture never be clear. We cannot determine both position and the velocity of an electron simultaneously. So uncertainty principle, which was stated by the Werner Karl Heisenberg in 1927, and this principle gives a very vital relationship between the momentum and the position of an object. This principle states that position and the momentum cannot be simultaneously measured with the high accuracy or the precision. There is a minimum for the product of the uncertainty of these two measurements. There is always the uncertainty, and we go for their uncertainty product. There should be always a value come up. So the mathematical expression given by the Heisenberg is delta x, which is the uncertainty in the position, delta p, that is uncertainty in the momentum, should be always greater or equal to h upon 4y. This much of the uncertainty should always occur when we determine the position and the velocity of an electron simultaneously. Erwin Schrödinger in 1925 derived a wave equation, refined the wave particle theory proposed by the de Broglie, and in 1925 he developed the equation which treated the electron like a wave and predicted the probable location of an electron around the nucleus, called the atomic orbital, and contributed the quantum mechanical model of the atom. He used to describe the second order differential equation for the wave motion of an electron in all the three dimensions or the orientations, that is x, y, and z. He got the Nobel Prize for this equation in 1933 and became that famous equation, Schrödinger wave equation. When we talk about the quantum atomic orbital probability determination, we always use this equation for the determination of the probability. So, by all the de Broglie concept and the uncertainty and the Schrödinger equation, we have the quantum mechanical model of the atom. So, this is the structure of the atom, which is said to be the quantum mechanical model. Around the nucleus, there is a three-dimensional region or a path where the probability of finding electron within a certain volume of the space surrounding the nucleus can be represented as a fuzzy cloud. So it's a three-dimensional fuzzy cloud where we can say the probability of finding an electron is maximum. That is the concept. This is the region, three-dimensional region, that is called the atomic orbital. The cloud is more dense where the probability of finding the electron is high. So that fuzzy cloud appearance, we can say, give us the three-dimensional region probability of the electron is maximum. If the cloud is highly dense, their probability is very high. So this is the main model, which is called the quantum mechanical model of the atom, where we always say that probability we can find out of an electron. The fuzzy cloud, which was described, is an atomic orbital, is often thought as a region of a space in which there is a high probability of finding an electron. You can see here the density wise picture of the atomic orbital. Here you can able to see the more dense part is just the inner part. The outer part is less dense, the inner part is more dense. So we can say the higher dense part give us the higher probability of finding an electron. The same you can see here, we can have the boundary also of the high probability range, because we can see that the more dense part we are able to see in the picture. We can make the boundary of that particular region, and then we can easily say that the maximum probability of an electron is this region. So that is representing by the fuzzy cloud. The fuzzy cloud is representing the atomic orbital region. So that is the quantum mechanical model of the atom. Now, as you have seen the fuzzy cloud, which relates to the atomic orbital, where the probability can be found, and it is of different shapes because the path according to the, it can be circular, it can be of the different orientation. So we have the different shape of the orbitals. That is, S orbitals are the spherical shape, that is the smaller atoms, fewer electrons are present in this, take up the less space. We can have the two s orbitals. If we have the larger atom, the size, we have more electrons and which can take up the more space. So the S is dimensionless, spherical like a ball. So it is dimensionless. If we see from any one side, we have the similar atomic orbital or the fuzzy cloud. So here we have compared according to the size, the s orbital. If the smaller atom is there, the electron are fewer and take up the less space. We have a larger atom, more electron, take up the more space. The next orbital is the p orbital, which is having the dumbbell shape, and the p orbital is having the three type of the orientation. It can have the x orientation, y orientation and the z orientation. So one kind of the orientation on the axis you are able to see. So it's the dumbbell shape according to the different axis. It can having the orbital shape. So this is actually the p orbital shape on the z axis. So that's similar. We are having the shape on the x-axis and the y-axis also. So the three type of the orientations can be possible in the p orbital. You can have here the p orbitals together. We have all the orientations x, y, z orientations in which this type of the shape of the p orbitals can be seen here. So all the x, y and z axis orientation are shown of p orbital. So in which the electron probability can be determined. So this is the p orbital of the different shape dumbbell. So having the three different type of the orientation where the probability can be determined. So next orbital is the d orbital. The shape of the d orbital is double dumbbell. So we have the five types of the orientation can be possible for the double dumbbell. Orbitals moving in the x, y and the z directions. So here we can have all the five shape of the d orbitals. The first one is dxy, dxz and dyz. The fourth one is dx square, y square and dz square. The three of the d orbitals are called mid-on axis as it is representing. So here dxy, you can see the x direction and the y direction. We are having one of the dumbbell is in between this x and y direction. The another dumbbell is in the another axis, but the one of the dumbbell is in between the x and y. So that is the dxy. dxz, we have the one of the dumbbell lobes is in between the X and Z. Can able to see here. That's why these orbitals are said to be on mid-on axis. So we have this in between X and the Z. The another can be on the axis, but if we are saying that is XZ, so that particular lobes of the dumbbell are lying in between the X and Z axis. The third one is YZ. So here you see Y and Z. So the Y and Z, it is representing this in between this axis, this lobe of the dumbbell, it representing the DYZ. According to the direction, you can make it very easily. Then on the x-axis, it is on the lobe. The fourth one is dx square y square. Dx square y square is representing on the axis. So both the dumbbell lobes are lying on the axis of the x square. So on the x we have two lobes, and this is the x-axis, we are having two lobes, and on the y-axis we are having two lobes. That's why it is said to be dx square. So as we go for dx square, we can easily on the, you just make the direction xyz, and then you can easily make the shape of the d orbitals representing dxy, dxz and dyz. So x square and y square representing on the axis, can easily make it on the axis. And dz square means on the z direction we are having both the double dumbbell. How it is representing? The one you can see on the axis, that is z. The another lobe is also on z axis, but it is rotating. Here you are able to see the one is rotating around, and the one is on the axis. So if we say the dz square, so we can make it the one dumbbell two lobes on the z axis, and the another lobe is rotating around that z axis lobe. So that represent the dz square. So dx square, y square and dz square are on the axis orbital, and dxy, dxz and dyz are the mid-on axis. So these are very important with the shape of the d orbital. We should remember, because these are very much used further when we see the splitting of the electron in the d orbitals with the various orientations. In the next lecture, we are going to learn the Schrodinger wave equation, that how if the probability of an electron can be determined. That's the second order three-dimensional equation, which gave the mathematical calculation to derive the probability of an electron, which become very important in the quantum mechanics. And also we learn about the quantum numbers, all the features which are explained in the structure of the atom, how we can just determine the location of the electron in the quantum number, and then see the electronic configuration of the elements. So all these points we will cover in the next part of the lecture, and till then you just revise all the model of the atom with the concept, features, and the drawbacks so that we can solve the queries related to this first part and the second part. So be prepared with your questions. Till then, thank you and take care.